Just like with classification, stochastic gradient descent is not an actual algorithm. Instead, it's an optimization technique that can be used to train models such as the linear regression model. If you remember everything that I've discussed in the earlier course where we used stochastic gradient descent with cross entropy to be minimized as an example, well, you can skip ahead and move on to the next video. If you feel your foundation concepts are not clear, then this video is worth watching. The stochastic gradient descent optimization algorithm iteratively adjusts a model's parameters to minimize its error. Other algorithms like decision trees, random forest, k-nearest neighbors, and polynomial regression. The reason that I discuss stochastic gradient descent here is that it actually becomes very important when we talk about deep learning with neural networks. This is also an optimization algorithm that's used for neural network training. Given its importance, it made sense to discuss this. In order to see how stochastic gradient descent can help train linear regression models, let's go back to finding the best fit line. Now, we've discussed the fact that the best fit line is one that minimizes the mean square error loss function. We are looking to minimize the sum of the squared distances of all of the points from our regression line. That's what will give us the best fit line on our data. The simplest possible regression model is what we have depicted here. It has just one x variable exercise. Now, the regression line equation for such a model has just two parameters, a and b, where a references the intercept of the line and b is the slope of the line. In order to understand stochastic gradient descent, we'll visualize the model parameters and the loss of the model in three-dimensional space. Along the x and y axis, I have the model parameters of our linear regression model A and B. However, these can represent the model parameters of any model that you're looking to optimize using stochastic gradient descent. Now, A and B can have any combination of values, and for different values of A and B, the mean square error of the model can be different, and maybe it's represented using the slope that you see here on screen. So for certain values of A and B, the intercept and the slope, the mean square error loss can be very high, and for other values, the mean square error can be very low. And for other combinations, it's somewhere in between here on the slope. The objective of training a linear regression model is to figure out for what combination of A and B is the mean square error the lowest. And by the lowest, we mean at the very bottom of the screen, where the slope is at its valley. So somehow, we've got to figure out what the corresponding values of the parameters A and B here in this example are so that we minimize the mean square error. That will give us the best possible model. And thus, stochastic gradient descent is the optimization algorithm that we use to walk down the slope from wherever we are to start off with to get to this minimum value of mean square error. Initially, when the model is untrained, we have random values for coefficients. A and B can be anything, which means that the mean square error loss can be anywhere here on the slope. So the green point that you see here at the top of the slope, that is the initial value of mean square error at the start of the training process of the model. Stochastic gradient descent uses iterative optimization to walk down this slope of the mean square error by tweaking model parameters till it finds the model parameters that correspond to the lowest value of loss, the lowest value of mean square error. The term gradient descent in stochastic gradient descent refers to how the algorithm walks down the slope. Imagine you're standing on a hilly landscape in the dark. This loss function slope is essentially a hilly landscape, and your goal is to get to the lowest point in the valley. The gradient is a mathematical computation that serves as a compass. It tells you the steepest direction uphill from where you're standing, and to get to the bottom of the slope, you take a step in the exact opposite direction of the steepest direction, that is downhill. This is how the gradient works in machine learning. The gradient is a vector that points in the direction of the steepest increase of your model's error, So you take a small step in the opposite direction to reduce your model's error. This process is repeated multiple times, taking many small steps till you eventually reach the lowest point of the error, that is the valley, which is where your model performs best. This is the classic gradient descent algorithm, and stochastic gradient descent is one variation of this algorithm. Instead of calculating the gradient on the entire dataset, which can be computationally expensive, SGD computes the gradient on a single randomly selected data point at each step. This single data point is often referred to as a stochastic sample. By selecting one data point at a time to compute gradients and walk down the mean square error slope, stochastic gradient descent iteratively converges to the best model.